The first speaker is Máté Kovács. Máté, are you ready?
Yes, I am.
Okay, so Máté is from Braid Technologies, and he will be telling us about a Rust wrapper for MFEM. So this is, I think, going to be a talk that will be of interest to a lot of people in the audience. I, for one, am very, very interested to see the work that Máté has done. So please take it away.
Thank you so much. I'm very excited to be here. A little bit jet lagged still. Let me start with a confession. I've been pronouncing MFEM. Oh. So it's kind of difficult to recover from that, but I'm really trying.
What were you saying?
Yeah, I don't want to say it. It's going to mess me up. But nice try. I'm excited to talk about my Rust wrapper for MFEM. A couple of words about me. My name is Máté. Very nice to meet you all. I've been a C++ enthusiast for a long time, but apparently not longer than MFEM has existed. Starting today, it's pretty cool. I'm also a huge Rust fanboy ever since 2016 when I tried it for the first time, and I really like it. I think it's a great language to learn for anybody who is into C++. They're actually super similar. I've dabbled in MFEM since 2021. I use it mainly at work, but I'm also trying to learn about it because I'm really passionate about physics simulation, and I think it's a pretty cool library. It's also huge, so it's a large undertaking to learn anything about it. And I'm organizing the Tokyo Rust community as well. If you're into Rust and you happen to be in Tokyo, just feel free to shoot me a message and we can grab a coffee. All right. People, how many of you have used Rust? Or video mix? 3 people. That's actually more than I had expected. Right, Rust wrapper for MFEM. These are my key points. If you remember these, I'm really happy. So I want to talk about how MFEM will benefit from a Rust wrapper. And then I'll give a quick overview of the wrapper itself. And I have a call to action for you, which is please help build and maintain it. Let's start with the benefits of Rust wrapper from the point of view of the MFEM community. I really believe that it would make MFEM easier to use. It would lower the barrier to entry, and that's because Rust has more compiled time checks that help the user learn how to use some sort of a library API correctly. And it's much more difficult to mess up than when you're writing C++ code. I'll have an example of this. And another big selling point of Rust, as I found using Rust and C++ side by side on a day-to-day basis for a long time now, is that Rust has very universal, friendly package management and build tooling. So you don't have to learn lots of different ways of doing the same thing. You learn it once, and then it works the same way for every library, every application, so on and so forth. And I will briefly talk about how C++ and Rust are basically equal in terms of performance. So you don't have to worry about you're getting a performance hit by choosing to use Rust instead of C++. And it also has very robust and low overhead ways to integrate with C++. So if there's something that is only available in C++, not MFEM, you can still use it from Rust. There's also an incoming wave of adopters on the horizon. There are 2 data points here I would highlight. There's a big DARPA project to auto-convert C code to Rust. So we're obviously pretty serious about it. And the White House had a press release, I think it's still up on their website, where they talk about on a champion memory safe languages. And that's a great example of which is Rust. And last but not least, there's already a Python wrapper. So why not Rust? All right, now I'm going to talk about the wrapper itself. It's called MFEM RS. This dash RS part is mentioned in the Rust community for naming wrappers that come from other languages. Here's a quick summary. It's already available on the Rust community's registry. So if you go to crates.io/crates/mfem, you'll see this wrapper. It has automatically generated documentation on docs.rs/mfem. You only need a single line of configuration to run this package from your rough project. And you can even choose to link against MFEM compile that's already on your system, or you can choose to have it built from source and then hands off. And once you have an application written in Rust that depends on MFEM, you can build and run your code with a single command. And last but not least, you can use MFEM from genetic Rust code, so that you get a lot of compiler provided automated checks to ensure that you're using it correctly. So I'm going to talk about these compiler checks in detail now. For example, imagine that we're writing this MFEM app in C++. Can people see that from the back? Yes. I'll leave that on for a little bit, but basically we have this function that is constructing a grid function with a mesh. We want it to factor this out, so it's a separate function. We're loading a mesh, we're calling this thing to make it access the grid function, and then we need one to project one. Well, that will do something else with it. Right. This was kind of okay. So compile it, we're happy, everything looks fine, and then anybody care to guess what will happen next? Crash. Angling reference. Here's segfault from here. Yep. Yeah, we're gonna get a segfault. It's not obvious to me at all why that happens. I've used MFEM for a while. I've also used C++. And I think it basically doesn't matter how much experience you have. Sometimes you hit these mistakes. And one cool thing about Rust, we're going to write the same thing in Rust now. It will look like this. This is using the MFEM wrapper. Pretty much the same thing. We have each same function factored out. Things look a little bit different because of different conventions in naming things, and using snake case for methods and so on and so forth in Rust. But it's pretty much one-to-one with the C++ code. And if we try to build and run it, the compiler will immediately tell us, hey, you're doing something here that does not look okay. In fact, we get two of these errors that are basically the same thing. We are trying to return something from the function that only exists as a local variable inside the function. And it's a very detailed explanation, as you can see. It's directing you to a piece of code that has the problem. And then if we were to run Rust C with that flag, it would provide an even more detailed explanation of what is going on. And by using the MFEM Rust wrapper, you automatically get all these checks. Next up is the package manager and build tool situation. I feel like the situation for C++ looks like this, where there are lots of different tools that basically do the same thing. To be honest, I've used a fair number of these, but I don't know, can anybody name all of them? If you can't, please raise your hand. What is the one? The first one is called Buckaroo. Yes, this one is Ninja. So I have personally used Roman and Basil, CMake, this package, Ninja, somewhat familiar. And I feel like every time I'm reading a new C++ code base, there's a high chance that I have to learn a new language that I've never used before, because there's so many of them, and people just try to make informed choices about what they think is good for their own project. But this is kind of a mess. If we're being honest, from a newcomer's perspective, it's definitely not ideal. On the other hand, Rust only has one build tool, it's like cargo. And I keep repeating this. I used to not know who it was attributed to, so I looked it up, and it's by this person called Cornel Leshinsky, who's a fairly prolific contributor to Rust. And he said the best thing about cargo is not any of its features, it's just there's nothing else. So everybody just uses cargo, which is great, because when you're onboarding onto a new Rust project, you're reading somebody's library, you know it uses cargo, and you already know cargo. There's also a lot of community infrastructure built around it, because it's the only one. So this is where all the effort is going. Crates.io and lib.rs are two main sites where you can discover Rust packages. They're called crates. And there's also docs.rs that just automatically gets documentation built and uploaded to from Rust projects that are on crates.io. So I'm going to show you what this looks like from a practical perspective. We're going to set up an MFEM app in Rust. It's basically 3.5 commands that we have to run depending on how you're having this, creating the directory and going into it. Then we say cargo init. It says, okay, create a binary application package. And we say cargo and MFEM. We're adding this dependency. Well, pretty well. It added the latest version that they found on Braid.io, which happens to be 0.0. And its features automatically enabled. This is the default bundled, which means it will build your MFEM C++ library internally from source code that is bundled with the project, so you don't have to do anything. This will work even if you don't have MFEM installed already on your system. And once you've done this, this is what the layout of the project looks like. It's also standardized, so everybody knows what these projects look like. Nobody's surprised. You get in the source tree, the directory called source. Inside there's main.rs that will contain the code of your application. You can add additional modules in here. And then there's this cargo.toml file that contains the manifest for cargo, like the name of your app, version. You can pick what edition of Rust you want to use. Editions are sort of like C++, 11, 14, 17, and so on for C++. And here the dependencies are listed. We're only depending on MFEM. All right. And I will briefly talk about performance now, because I feel like performance is always a concern for veteran C++ programmers when they're being told about potentially switching or trying out something else. Like when people hear, okay, high MFEM, I'm guessing they have this thought of maybe if I write it in high MFEM as opposed to just vanilla C++ MFEM, it's going to be a little bit slower. Or when they hear the word, high MFEM as auto-generated bindings, maybe the performance hit that I'm including there. And I just want to convince you that this is not the case for Rust. And C++ and Rust are way more similar in terms of performance than people usually expect them to be. There's this big suite of benchmarks called the benchmarks game, where people can submit their implementation for any of these problems in lots of different languages, and then they pick they benchmark all of this, and then they give you a big data set that shows you how to perform. And as you can see, I picked the best for both C++ and Rust from these data sets. They're compared total execution time, total memory consumed, and how big the source is if we gzip it. Highlighted smaller is better for all three of these, and I highlighted the the better one. And I gotta say, it's pretty even. So sometimes C++ is better, sometimes Rust is better, but there's no obvious like total order. Yeah, I'll let you go and look at these numbers in more detail if you want to, if that's the source. And so this is just a comparison of the performance of the languages themselves. And this is about the performance of the binding that FMRS uses to hook into the C++ MFEM API. The sort of key thing I want you to read is this, which says the binding operates at basically zero overhead, no copying, no serialization, no memory allocation, or runtime checks involved. It's just a long-winded way of saying if you're writing your thing in the MFEM Rust wrapper, you should be expecting to get roughly the same performance as if you wrote it in C++. And yes, there's a lot of future work. Obviously, this is a prototype that I built in a short amount of time. There's a lot to do. The main one is to incrementally extend API coverage so that all the examples can be translated. I think the examples are great for learning MFEM, and it would really help if all of them were to be translated to Rust as well. The second point is help streamline the MFEM API, especially around cost correctness. I will talk about this in a little bit, why this is super important for Rust. Then make it work with MPI. I expect that to be a larger undertaking, even though there is already a Rust crate for MPI support, because MPI support needs integration with the compiler. It's kind of tricky how to make that work with Rust. There are some examples. So I hope, and then obviously cover other components like Hyper that are exposed on the FBI API. So MFEM API. Please help. Here are 3 ways in which you can help. First, just try it out, give it a spin. Try writing something small, anything that comes to mind, and give feedback, file issues on GitHub. Second, help streamline the MFEM C++ API. Big one, so I'll come back to it later. And then last but not least, if you know Rust, those 3 people who raised their hand here, please contribute to the Rust wrapper. So if you want to try it out, this is how you can do it. First, you need to get Rust. You can go to rustup.rs, follow the instructions there. It's pretty straightforward. You will get all the Rust toolchain, including compiler, Clarko, and some other tools installed on your machine. And then just follow the steps that I was showing earlier in this talk. Create an MFEM app that depends on Rust. And sorry, the other way, a Rust app that depends on MFEM, and put some source code in main.rs. Try to make it work. And if it doesn't work, or there's something that you can't find, file an issue on the GitHub project, and then consider contributing the necessary changes. All right, now streamlining MFEM C++ API. There's this notion of cost correctness in C++, just basically if you mark something const, it means it cannot be modified, and the compiler will enforce this. This is even more important in Rust than it is in C++, mainly for the reason that Rust has this additional constraint that every piece of memory may have multiple read-only references to it, or a single reference to which it can be mutated, modified, and the compiler will enforce this rigidly in a static analysis kind of way that in any part of your code, any point in time, this constraint has to hold. You cannot have both reading and writing references to the same thing. And they do this mainly because it simplifies writing highly performant concurrent code that has no checks, no exclusion primitives, but there are other reasons as well. And the consequences of this that are reflected in the design of the language is that variables and references are immutable by default. So instead of having the const keyword, Rust has the mute keyword, which you have to use to mark something mutable. And this means that because const is the default in Rust, these cases where it looks like a const marking is missing from an API makes the API much more difficult and limited to use from Rust. So as an example of this is project coefficient, which from the semantics, it feels like the coefficient that is being projected onto the grid function should be const, like should not be modified. It's in one way to think about it is it's basically on the right-hand side of the assignment, but because it's not actually marked const with function signature, I'm just guessing the reasons for that. But this basically means if you want to use this from Rust, you have to pass an immutable reference in there. That means when you define the coefficient itself, you also have to mark that mutable. Otherwise, you cannot have a mutable reference to it. And it just sort of this mutable marking pollutes everything in your code. So I'm guessing that in this case, project coefficient is like this because the eval function on coefficient is also not const. There are probably reasons for that as well, but I would hope that these sort of nits can be incrementally cleaned up. And I really believe that by doing this, we're actually also improving the MFEM C++ API, encoding more of these explicit concepts. And right now, MFEM RS has lots of ugly hacks to get around this, which likely make it unsafe. It's not great. Okay, and contributing to MFEM RS, I'm guessing I'm sort of running out of time here. So I just put a link here to an example course that you can look at, and it shows all the places where you need to modify code base if you have the new method. This one is adding project coefficient on grid function. Zooming out a little bit, what makes me super excited about the possibility of having this wrapper for MFEM is the ability to bring together modeling and simulation for Rust. I have a really good friend, his name is Ryan Schwind. He also used to live in Tokyo and then moved to Okinawa. Before that, we used to hang out all the time. He also likes building stuff. And he maintains the Rust wrapper for this really old school and widely used open source BRAP kernel called Open Cascade. It's used, if you've ever used FreeCAD, for example, it's running on top of Open Cascade. So he maintains that. I've been helping him out with it, and I'm trying to build the same thing for MFEM. And why this is important is once you have both of these, you can do end-to-end modeling and simulation in a Rust app. So you can compute a shape using Open Cascade and do all sorts of testing and analysis on that shape with MFEM, never having to leave Rust in this process. So it can be a single code-based, single application. You can share functionality that you build as cargo crates, so for generating shapes or functionality that is useful for generating shapes, and also for doing the analysis using MFEM. And you can easily build on top of other people's work the same way. You will publish your own. The missing piece is a package for mashing VRAPs. That's all I got. I wanted to give some special thanks again to Brian Schwind, who taught me about the CSX crate that I'm using to bind the MFEM. His Open Cascade RS crate served as both my inspiration and copyable setup that made my life really easy. Short Stonkers that I used to work with, you can move back to your, was my sort of wisdom for writing performant modern C++. And last but not least, my friend Luke Pearson, who helped me read this talk. Thank you for listening. If you'd like to connect or learn more about my projects, my website. And I have another version of this talk. It's both longer and more oriented with more details. You can watch it on YouTube.